Hi, I'm Eric Gadby, and I have been an enthusiast for all things nautical and aerospace since the age of 10. I served for 22 years in the U.S. Submarine Force and have been supporting it for the last 15 years since retiring. Join me as I pursue my passion for first-person context for ships, aircraft, and historic sites that have shaped our world, as well as some that are off the beaten path. Welcome to Heritage Hill, located on McChord Field on Joint Base Lewis McChord, just south of Tacoma, Washington, home of C-130E Hercules Tail Number 62-1789. All right, well, welcome to the cockpit of the C-130E here at Heritage Hill on McChord Field, Joint Base Lewis McChord, just a little bit south of Tacoma, Washington. I'm sitting here in the pilot's seat, and this aircraft is a E model. Dates back to 1962 or 66. I can't remember when the E model came online, but there's a lot of analog in here. That's been some upgrades over time that have bring in some digital here. But we have the basic flight instruments that you would see in just about any other cockpit: artificial horizon, distance, direction finding, radar altitude, radar altimeter, just your standard, navigation gauges that or instruments you would find. Center console, you have each of the four engines is represented here, 1, 2, 3, 4. You have torque, RPM, engine inlet temperature, fuel flow, oil temperature, engine oil pressure, then oil quantity, and then each of the four engines has a scoop on it, a flap that actually controls the amount of air flowing through the oil cooler, and this is an indicator of what position that flap is in, and so you know how much is tracking for temperature versus how much air you're bringing through it. Okay, it is a turboprop. The engines spin at a constant RPM. The throttles here, actually you put it, and let's see, this would be the all the way forward takeoff position. That brings the engines to 10,840 RPM. It hits a notionally just a little over 10-to-1 reduction ratio in the gearbox to turn the propeller at 1,042 RPM. So then once the propellers are spinning, you have the pitch. Each one of the four propellers, you can go from feather to full pitch on it, maximum thrust. So that's what actually gives the aircraft the forward momentum, or in the case of, you can actually, pitch it back for reverse, and actually can back this up, and it can shorten your braking distance. Okay, on the co-pilot side of the cockpit, you have essentially some of the same instruments. Landing gear, that's the standard knob that is molded to feel like and look like a tire. You have the hydraulic plant controls. There are 3 hydraulic systems on the aircraft. The utilities system is powered direct engine driven auxiliary off of engines 1 and 2. The booster system is engine driven off of 3 and 4. And then the auxiliary system is an electrical system that has its own pump and accumulators that are in the aft of the aircraft. And we'll take a look at all of those as we go through the walkthrough here. So continuing on through the center of the console, you have basically for trim of the aircraft, you have rudder trim, and then for the essentially elevator trim. Then flap selection. This is percent extended, not actual degrees. So there's an actual lockout here on the front that you have to click to allow it to come down. Then basic communications, VHF, UHF, IFF for the aircraft. Now we're going to go up here to the overhead panel that starts out here for engine start. You have push to start, then pull to stop on these. So you would, as you would run the engine up, you'd hold it in until it reached its initial, self-sustaining, and then it would go into a, self-sustaining run. Okay, then we have for extinguishing, their engine 1, 2, 3, 4, and the APU. This goes to their discharge agents. There's 2 bottles, bottle 1, number 2, that are in the port mid overhead. And what they are is 37 pounds of, and I'm going to mess this up again, it is bromo trichlorofluoromethane, which is a form of freon, which would extinguish any fire in it. So you have 2 shots to do it. If you had fires in 2 engines, you'd do it once on the engine from one and then to the other, or if you had, a situation where you would could do it twice on the same engine. So the next panel here, you want to give it a little light over here, Mike. This is all about fuel. So you have main fuel tanks for 1, 2, 3, and 4, and those feed to the booster pump dedicated to engines 1, 2, 3, or 4. Then you have aux tanks 1, 2, 3, and 4, and then we have the external tanks here. So the system allows you can cross connect to feed from one pump to another portion of the distribution network, but as normally architected, it should be pump 1 to engine, or tank 1 to engine 1, tank 2 to engine 2. Okay, move further up the panel here. This is all about the electrical system in this section. So you have engine 1, 2, 3, 4, and APU. These are the AC generators that feed into the left half and right half AC buses, which also feed to the essential AC bus. These engines would normally provide the generation for that, but then you have the essential DC bus. These feed into and can actually provide AC power to the essential AC bus through rectifiers that off of the battery whenever you have a loss of all AC power. Then rotate up a little bit further here. This is all about the bleed air and pneumatic system, anti-ice, cabin pressurization, and air conditioning. Those are all controlled from here. So cabin pressurization is this panel that have the controls for and monitoring for anti-ice and for bleed air. And if I remember correctly, the bleed air comes off of the 5th and 10th stages of the compressor, and that because of the heat concerns, because if the air makes it all the way through all 14 stages of the compressor, it leaves there at 125 psi and a temperature notionally of 600 degrees Fahrenheit. So for anti-ice, you'd actually need it to cool off before you could use it. You don't want to, that's near the melting point of aluminum if it got any much hotter. So you have to be careful about that. So on the other things on the co-pilot side, if right there on Mike's right hand, those 4 things that you see, those are controls for the propellers, for the actual pitch mechanism. So feather, that the system that controls it is monitored and controlled from there. And other than that, you have a large section of AC and DC fuses and switches on the panels here. It's a early, mid-50s aircraft, so there's going to be a lot of stuff that would normally get rolled up or was eliminated as we came through, technological, iterations. And so then the next station, next to Larry there. Now I'm in the Navigator Station. This obviously they would have charts out laid out for their route. You have here, this is the radar scope. There's actually another one in the center of the console, both for navigation and weather avoidance. We have all of the basic, altitude, radar altitude. They have a VOR and attack end here, as well as for communication, radio direction finding and fixing, and other radio controls. So this station would provide, where the aircraft was and recommendations to how to navigate the aircraft to the pilots and interface with air traffic control. So up here in the overhead, nice little section right there. You have in the era of before GPS, this actually was a sextant. You could put it in and take azimuths to the sun and to the moon and the stars. Allow for navigation, old school, style. And that is the Navigator Station. All right, gonna walk into the C-130E here, main entry door. And immediately this is the Avionics Bay for all of the communications, radar, flight control stuff, as well as the wheel well. That's what you see there. I have a crew galley that would have oven and refrigerator if this aircraft were in service. Now I'm going to make a nice turn here to go into the cargo hold. Give you a look here. It is obviously a lot smaller than the C-141 that we were in last week. But we have Sean from the museum with us again. Hi, Sean. So these are the standard seats that you would see for combat troops and to sit in. I've flown in this aircraft when I was on active duty, and yes, they are, whenever you're knee to knee with other folks, they are not the most comfortable seats in the world. So moving along here. So there is, right here, there's you pull this, and it allows you to hand crank down the landing gear. It's a high torque system, but in case of a hydraulic failure, you can crank it down on the flaps, down or up there. That's for the flaps. The landing gear is off of this one. So flaps on this one, landing gear on this one. And that releases the landing gear. And behind this is the hydraulic accumulator for the, want to get it right, the I'll remember it in a minute, but port side engines 1 and 2 drive the hydraulic system that loops through on that one. Then on the other side, you have the boost system. It's located up in here. And the same thing here for landing gear down, landing gear up. And the T handle is here. Going to continue on. You can see up in the overhead, this is a 1950s era ducting, control cables, and everything that you would see, as well as the bleed air coming in to pressurize the cabin. And make our way back here to the aft part. We have more seating, but also we have on the port and starboard side, there are doors that roll up into the vertical tracks that you see here, up and into position there to allow for paratroopers to exit the aircraft from there on both the port and starboard sides. And then there is indication up here, red light, green light for the, from the cockpit down to let them know, as well as a bell. And as far as creature comforts go, this is what it looks to be. There's a urinal behind here, as well as a chemical or a storage toilet. Then you have the auxiliary hydraulic system here. This the AC pump, hand pump, and then you have for stowage up here. For these are like coffee or water. Okay, I am standing on the rear cargo ramp. This works in two pieces. The piece you see up there, that pulls up to here, up out of the way. And then the bottom portion translates down to either be a ramp, if you're on the ground, or it can come flat to allow for pallet loading and inloading with, forklift, heavy equipment, that kind of thing. So more creature comforts, food, or not food, drinks here. Another urinal. Yes, there's a little platform. This comes out, and that's what you use, and it is as user-friendly as it looks. And I'm going to come along here along the starboard side. And then we're okay, we're going to do a walk around of the C-130E here. So forward landing gear. It's a tricycle setup. You'll notice that the wheel gear is very, very far forward on the fuselage, gives them good turning characteristics and puts the wheel directly underneath the pilot and co-pilot. It's hydraulically steered with a little tiller wheel up in the cockpit. You can see this door here opens out, and then the wheel rotates up, and then that fairing bears back in, and this pops back into place to give it a nice smooth surface. Inlet for cooling. Just gonna walk along here. Gonna get up to the main landing gear. Very large balloon tires. It's designed to operate on unimproved surfaces. Anything from sand, dust, mud, muck, you name it. This is designed to handle it. 2 wheels on each side. And now for the business end. It's powered by 4 Alison turboprops. So the actual turbine engine part of it is back here in the back portion. It is a 14-stage axial flow compressor, 6 combustor cans, and then a 4-stage actual turbine that powers at a single RPM, 10,840 RPM to the reduction gearbox up here in the forward portion in front of the prop that reduces it down to 1,024 RPM constant speed. So it is designed to the propeller blades twist for pitch to give it either more bite or less bite. And you'll see on the front there, that is the inlet for inlet air coming into power for the turbine. Then you have the oil cooler inlet, and then back here is a flap that determines how much air flows through the oil cooler. Moving along, every C-130 you see has these external fuel tanks. This adds an extra 1,360 gallons, or just a smidgen under 9,000 pounds of fuel on each side, so a total of 18,000 on the external tanks can be transferred up into the main tanks. And continuing along, the wing is, this airplane is not designed to fly very fast, so the wing is very simple and is a very straight line. There's no sweep to it. It is not like a jet where it's meant to be rugged, it's meant to be easy, it's meant to be solid. And just continuing around here. And if you want to take a shot up here, very large ailerons, gives a lot of control authority, even at low speeds. So that would allow, control as you're coming in. Then you have flaps in here behind it. These are the only high lift devices on here. There's nothing on the leading edge. Just trailing edge flaps. They're a single piece. There's an inner, it's a smaller one, and an outer, which is a larger one. And we'll come up here to pop open. So this is how you actually fuel a C-130. Pop this off, connect the pressurized fuel. You have selector switches for each of the tanks, quantity indicators. So this would be where you gas up the Herc from. Now these are what you connect the rocket-assisted takeoff RATO bottles to. They connect on here, and each one of them, I believe, is 1,000 pounds of thrust for the duration. They stack them on, 1, 2, 3, 4 of them, 4 on the other side. So they provide a rocket that powers for I don't know how many seconds, but once they burn out, there's a release mechanism on the inside to manually release the rockets, and they would fall away from the aircraft. Rear cargo or rear personnel door, this is rolls up inside, and this would be where the parachute, the parajumpers would come out of. So they would fall away, static line. Okay, up to here, this is the rear cargo ramp that actually can translate down either flat with the cargo deck to ease loading in and out of the aircraft with rollers, or it can actually come all the way down to be an actual ramp. It's it's about this thick, and there are smaller ramps that actually ferret out to provide a drivable surface to get in with a Jeep or Humvee or something. This portion pops, it's hinged on the aft, and it goes up, and that would provide the entire cubic volume of the cargo compartment to be able to be opened for loading and unloading. Another interesting part is that the horizontal stabilizer is fixed. It's very large and has very, very large elevators on it and elevator trim tabs. So instead of having a movable horizontal stabilizer, it is a fixed one and just has very large elevators to go with it. And if you ever wonder what these little guys are here on the trailing edge, I'm sure Mike will love static buildup.
Static wicks.
Static wicks. Now if you want to turn around and catch the rudder, you'll see that the rudder is a single piece, but there is a trim tab embedded in it to allow for, as the aircraft might be canting or kiting as it's coming in. And just a nice look back down the length of the aircraft, and you can just see how large the volume is. Get a good cross section. And like I said, very large elevator, lots of command authority for it. Then we're going to continue along. We have the port side jump door, the rocket assisted or RATO takeoff, bottled connection points here. And just like on the other side, the 1,360 gallon tank. And pretty much everything out here is just symmetrical from the other side. Since this aircraft was designed to operate remotely unsupported, it does have the terminology that they use is gas turbine compressor and generator, but affectionately known as the APU or auxiliary power unit. It is located in here, provides electrical power as well as pneumatic, compressed air to start the engines, to get everything self-sustaining without having to need of a start cart to do it. That's located inside here. And normally the exhaust would be, this is covering up the exhaust. And back to the forward entry door where we went in earlier. This rotates down, provides a nice set of steps so you can ingress egress without having to use any support equipment out and about. And battery compartment. And then behind here, this is the weather radar, and for navigation has displays up inside the cockpit between the pilots as well as for the navigator. Helps for avoiding storms, and could provide for navigation. You could overlay and actually get your position using a radar fix. But that, my friends, is the C-130E Hercules. Thanks for watching and for sticking around to the end. I truly appreciate all of your views, likes, comments, and especially for those who are returning subscribers to the channel. I especially like hearing from those who have firsthand experience with these aircraft, so keep the comments coming. I would like to extend a special thanks to Sean Zawada and all of the staff at the McChord Air Museum for their work in restoring and keeping these amazing pieces of history available for future generations to enjoy.